there, thanks for watching this video. So today what we're going to be exploring is how to apply our equations and inequalities to real life scenarios. Recently in this unit, you've been learning how to solve inequalities. You might remember from our previous unit, we learned how to solve equations. So the goal for today is to actually go through a bunch of these real life scenarios and determine if they should have one answer or if they're going to have lots of possible answers. And we're just going to go through lots of keywords together. To make it kind of easy for you all this school year, we've got the equations or inequalities already listed as answer choices, and you're just going to kind of have to come through here and match. And then next school year, by the time you guys get to algebra, you would be able to write one of these on your own without having them in front of you and just having to pick A, B, C, or D. Now, the first scenario here has to do with a suitcase and flying. And we have here that Blair's suitcase has to be no more than 50 pounds to fly. Now, some of you might have flown before, others might not have. So when you fly, you actually really have two options. You can carry on your luggage, which means you've just got a small bag and it can fit up here in the overhead container. Or if you're going to be kind of on a longer vacation or have more stuff, sometimes maybe if it's like winter time and your winter clothes won't all fit in the small suitcase, you might need to check a bag, in which case after you land, you have to go to baggage claim and get your suitcase. So it really just kind of depends on how you're traveling, but I wanted to mention that there's really two ways to carry a suitcase. You can either put it on the plane up above you, or you have to check it and they'll put it under the plane and you go get it when you land. So that being said, Blair's suitcase has to be, and sorry, there's a little typo, has to be no more than 50 pounds to fly. If the empty suitcase she plans to bring weighs 8 pounds by itself, so this is a suitcase. Right now there's nothing in it, it's empty, and already it weighs 8 pounds. Now remember, it can weigh no more than 50 to fly. So we want to see here which one of these inequalities can be used to determine how much stuff she can actually pack and put inside the suitcase and keep everything, it says no more than 50. Now you might remember here with a key word here, if it's no more than 50, that means it has to be less than or equal to 50. If I said that you can be no more than 13 years old to play on our team, well, 13, you can still play on the team. You just can't be more than the 13. So you could equal, and that's why I have that or equal to symbol there. So notice I'm just going to come through here and I'm going to eliminate a couple of answer choices based on that fact and that fact alone. Now, the 8 pounds she already has, plus what she can pack, has to be less than or equal to the 50. So now let's come through and look here, and we see it right there in answer choice B. Here's the 8-pound suitcase plus whatever she's going to pack inside of it, can be no more than 50 pounds. All right, cool. Now we're on to the next one. So for the next one, Andrew biked a total of 5.2 miles. Automatically, that lets us know we're dealing with an equation. So if Andrew biked a total of 5.2 miles, he went to school and then he went to his friend Noah's house. So if Andrew biked 1.6 miles to go to school, which of these equations can be used to figure out how far he went to get to Noah's house? So here we have it in a picture. This is just the problem up here again. So when he starts, like it says, he biked 1.6 miles to school. So here's 1.6 miles to school. Then from school, Andrew goes over to his friend's Noah's house, which is a total of 5.2 miles away from this starting point. So the 1.6 plus our unknown gives us the 5.2 mile total. So if we look at the answer choices here, we're looking for a total of 5.2. Now I see a total of 5.2 right here, and I see a total of 5.2 right here. I don't see answer choice D being set equal to the total, and I don't see answer choice A being set equal to the total. If we look carefully between the two, we can see that it's going to be answer choice C. It shows the distance between school and Noah's house plus the 1.6 miles he went to get to school is the total of 5.2 miles. So number 2 was answer choice C. Now I know a lot of you own these Funko Pop toys. So Eduardo here, we have Eduardo owns 7 fewer than Victor. So the first thing I want to ask you real quick, just based on that and that alone, if Eduardo has 7 fewer than Victor, who owns more? That's just a simple, quick comprehension question. If Eduardo has 7 fewer than Victor, that means that Victor here has more. So whatever number we get here for Victor should be more than Eduardo. Now we're told that Eduardo owns 21. So Eduardo owns 21, and that is 7 fewer than what this person has over here. So if I want to know how many this person has, it's going to be a 28. The concern that I have is a lot of you might see the 21 and the word 7 fewer, and you might be really tempted to come over here and do a 21 minus 7 and tell me that the answer is going to be a 14. Now that's incorrect, because we know that Eduardo is 7 fewer than Victor. So take Victor and minus 7, and you should have what Eduardo has. Now, if we know Eduardo has the 21, and again, I'm just showing you how it models over here into a equation. This is us showing that Victor minus the 7 would give us Eduardo. So if I add the 7 when I solve, there's the 21 plus 7, giving me the 28 that Victor should have. Now, I don't want you to think that this is overcomplicating the problem. The goal of this worksheet is to be able to take all this stuff in English and translate it into an equation and then use that to solve. And like I said, I know that that's this over here. This would not be something that you can do on your own as of right now. That's why we've kind of got them up here where you just try to identify and match which one you think would be the one that works. All right, now we're on to number 4. So for number 4, Keith withdrew $50 from his savings account at the beginning of the summer. Now, the moment you see the word withdrew 50, I want you to be thinking of minus 50. If you withdraw money from an account, you are taking money out of the account. Now, he wants to have more than $180 in his account at the end of the summer. So there was my keyword right there. He wants to have more than the 180 in the account. Now, when we look at our answer choices down here, we didn't ask which inequality below accurately displays this situation. If X represents the starting amount of money, okay, at the beginning of the summer. So we don't know how much he started out with at the beginning of the summer. All I know is that he withdrew 50, and we want this amount right here to be more than 180 by the end of the summer. So I'm looking for X minus 50, and that's why I'm going to get rid of this answer choice and this answer choice. So C and D both show a starting amount minus the 50. And if we want it to be more than 180, we can see right here, it's going to be answer choice D, because that has the greater than or more than symbol for more than 180. All right. Now that we've seen a few examples, let's just look at these 3 quick scenarios and try to just identify some keywords to see if we think we're dealing with an equation that has one answer or an inequality which is going to have lots of answers, okay? So for the first one we've got, let me get my highlighter out. It will cost Sarah $46.88 for each day she wants to attend a particular theme park. If she has $600 to spend, what is the maximum number of days that she can go to the theme park? Notice in this case, there's not one set answer. We don't know how many days Sarah's going to go. We just know the most days that she could afford based on the fact that she has $600 to spend. So what I'm going to do is I'm going to just drag this up here so we can see what we're looking at. This is the 46.88 for each day. And she has only budgeted $600 to spend. So if I now want to fill this in with a symbol, we got to see, is that going to be an equal sign or an inequality sign? I think you guys already know it's going to be an inequality symbol. Now we just got to figure out which one and which way it faces. So if this is 46.88 per day, and this is the most she can spend, this right here has to be less than or equal to the $600 that she has budgeted. So that would be an inequality because she can spend no more than the 600, and so it's less than or equal to, and so we'll circle inequality for this one. All right. For the next one, Andrew charges $35 every time he cuts a customer's lawn. Let me get my highlighter, sorry. How many lawns will he need to cut if he wishes to make at least $850 tomorrow? At least $850 tomorrow. So I think you already know that the at least lets us know we're going to have an inequality symbol, at least 850. So now let me move this one to right here so we can see what we're dealing with. So $35 per lawn that he mows, and he needs to make at least 850. So all of the money that he makes, we want that money to be more than or equal to, and sorry, my thing's freezing here. Let's get my pen back out. We want this to be more than or equal to the 850 that he needs. So this one's going to be an inequality. Remember, when you see at least, it's a greater than or equal to symbol. If you have a maximum, that's the most it could be up here. So everything needs to be smaller than or equal to that. All right, now for the last one here, Tamara spent $38 on a taxi. It looks like we're already been given a total because she spent something, it happened. The taxi company charges a $2.15 flat fee plus 85 cents per mile. How many miles was her trip? So if it's asking how many miles was the trip, that must be a set answer because she spent already $38. So right here, if this is the $2.15 flat fee plus the 85 cents per mile, that equals the $38 that she spent. So this one's an equation. And we could drop a line and solve by subtracting the flat fee and then dividing by the 85 cents per mile. And then we'd see how many miles her trip was. So the goal of this page was to just kind of go through keywords for when you're going to have an equation versus an inequality, and to kind of just help you start to see how to match these things up. That concludes the page 16 video. Thank you for watching.